Hi, let's take a deep dive into the new features in satellite multispectral processing and analysis in ProRaster version 4.1. So we're going to be looking at the Strait of Hormuz, some Landsat data, and you can see that on screen right now. In ProRaster, there's this magical little glue between your scene data that you acquire from your satellite provider and your rendering and your analysis, and that's called the Scene Assembly Virtual Raster. And in version 4.1, there are changes to that virtual raster to make it more efficient, and there's some new features. There's a new field called a constants field, and there's a new band in the mask field called pixel quality. And we're going to see what we can do with those things. So when you download version 4.1, if you have any existing scenes, any existing scene databases, the first thing that you're going to need to do is to update those scene databases. So let's do that right now. It's very simple. Go to the Browse Scenes button, drop it down, go to the Validate option and the Regenerate option, then choose your scene database and hit OK. This processing dialog will come up, and all that's done is gone through and regenerated those scene assembly virtual rasters, updated your scene database, and now you've got access to those new capabilities and that improved performance. Now, if you have any products created from those scenes, they are not going to be modified by this process. So they're all still going to work without any modification at all. So let's look at these new fields and bands that are in the Scene Assembly Virtual Raster. So open up my Hormuz scene database. I'm just going to switch to Scene Preview. And then let's just scroll down until we find a reasonable looking scene, something that has some cloud in it. Perhaps this one here. Right click and display the scene. So come into my color band. In the mask field, there's a new band called pixel quality. So display that here. This is a value between 0, which is low quality, and 100, which is high quality. And it's created on the fly from all of the QA information that's provided with the scene. So that's the cloud information and the different types of cloud. It might be radiometric saturation information, terrain occlusion, or terrain shadow information. All of these things that can adversely affect the quality of the pixels in the scene are combined into a single measure, which you can then use when you're doing compositing. So for this scene, we have red, showing high quality pixels, and then in those cloudy areas we have green going down to blue, showing very low quality pixels. So in addition to that, there's a new field called the constants field, and that has a number of bands in it. So in this case we have acquisition time, processing time, cloud cover for both the scene and for the land, and because this is Landsat data, we get the path and the row. So we'll have a look at this information when we've got a mosaic, when there are multiple scenes and we can see some variation in the data. So let's see how to use that pixel quality band to create a composite mosaic. So I've got my Hormuz collection. So in this collection, we've got a whole bunch of scenes, but some scenes have got multiple revisits. And what I want to do is put together a composite mosaic where I keep the best quality data and generate a single data set from all of these scenes. So it's merging them all together. So I select them all and hit Create Composited Mosaic Product. Goes into my Hormuz product. Now, firstly, let's do it the normal way. So normally I would sort by cloud, for example, from most cloud to least. And then I would clip and I would keep pixels that are clear. Hit OK. That will go into my scene product, into my product database. And then I can render that product. Choose some band combination. Might turn on pan sharpening. Hit OK. So this is a result from compositing where you're clipping out cloud, and wherever you've got scenes that are overlapping or scenes that have been repeated, pixels that are not cloud affected will be used to replace pixels that are cloud affected. But what we get, of course, is gaps in coverage where some pixels are cloud affected in all of the scenes and in all of the overlaps that we've got pixels. So the alternative now is to use pixel quality. So let's come back to, I'll just close that one down, come back to our scene database. Again, right click and say create compositive mosaic. Now I'm going to order by acquisition date from earliest to latest. So I'm looking at the latest data. I'm not going to use clipping. So I want every pixel to be returned, but I want the best quality pixels to be chosen. So now I can set my retention rule to by pixel quality, and that's going to use that pixel quality band that is new in version 4.1. Hit OK. I'm going to render now. Choose that same vegetation analysis and pan sharpen. Right, so here is my new algorithm, and you can see that we have cloud and we've retained all the pixels, but where some scenes are cloud affected, we've retained pixels that are better quality and removed those cloud affected pixels. So this is an alternative way to generate a composite. So let's go back to our first one where we had clipping, and I'm just going to add a lookup table color layer. I'm going to connect to this one. I'm going to go into constants and I'm going to do acquisition time. So now we're looking at the acquisition time. I'll turn on my tooltip and you'll see the acquisition time. So this is when we're clipping out the cloud, and you can see that we have big blocks of the same color indicating the same time for each of these scenes. Now if we go and do the same thing for the composite mosaic that we created using pixel quality, I'm going to add in my light color layer. I'm going to choose, I think it's H, go to constants, acquisition time. So now you can see that the acquisition time information is all mixed up. So we've taken pixels from different scenes and different acquisition times, and the data has all become mixed up. But we've chosen in all cases the highest quality pixels wherever they're available. So those are the new features in version 4.1 of ProRaster Scientific. Now the changes to the Scene Assembly Virtual Raster are in all tiers of ProRaster, so ProRaster Essential, ProRaster Premium, and ProRaster Scientific. But of course, the compositing capability only exists in ProRaster Scientific and is not available in the lower tiers. So thanks for watching.